So I'm going to be showing the solution to problem number 32 in chapter 3. So the problem goes, two piers in A and B are located on a river. B is 1,500 meters downstream from A. Two friends must make a round trip from pier A to pier B and return. One rows a boat at a constant speed of 4 kilometers per hour relative to the water, while the other walks on the shore at a constant speed of 4 kilometers per hour. The velocity of the river is 2.8 kilometers in direction from A to B. So the question is, how much time does it take each person to make the round trip? So first, let's draw the diagram that is provided. So here's the two piers. Here's pier A and pier B, and the distance between them is 1,500 meters or 1.5 kilometers. So we need to find the time for each, how long it takes for the boat to get from A to B, and then from B to A back, and then the total amount of time for the person walking from A to B and B back. So we have to find separate times for each of them. So first we're going to find the time for the boat. And we can find the time for the boat by using our position, one of our kinematic equations. We can use our position equation. So let's find the time it takes the boat to go from A to B. That is, the distance equals 1/2 acceleration times time squared plus the velocity of the boat plus the initial position. Now, in this situation, because the boat is traveling at a constant speed, this goes to 0, and because our starting point is just right here, because that's 0, this goes to 0 as well. So then to find the time for the boat as it goes from A to B, we just need to look at the velocity, velocity times time, and then we just solve for t. Now the thing is, with the boat, it's being affected by the velocity of the river. So the river, its velocity is going this way. So that would mean that the velocity of the boat as it goes from A to B is the velocity of the boat itself plus the velocity of the river times t. And then we can just solve for t in this equation, and then we have the amount of time it takes to go from A to B. So d1 is equal to, sorry about that. So then t1 is equal to d1 over vb, and that's the time it takes from going from A to B. Now we need to find the time it takes to go from B to A. Now in this situation, it's going to be, the velocity is going to be different because the velocity of the boat is now pushing against the river. That means the boat's going to be moving slower. So that means the velocity of the boat is going to be velocity of the boat, of the rower, minus the velocity of the river, because the velocity of the river is like pulling in this direction. And this gives us our second time. So then to find the total time for the boat as it makes a round trip from A to B and B to A, all we have to do is just add these two times together. So we just plug in our values, like 1.5 kilometers here and here, then plug in the velocities that are given to us in the problem. And then if you account for significant figures, the amount of time it takes for the boat to travel the round trip is about 1.47 hours. This is how long a round trip for the boat takes. Now we have to find the round trip time for the person walking on shore. And this one's much easier because the person walking on shore moves at a constant velocity of 4 kilometers per hour. And since he's on shore, he's not being affected by the river at all. So that means if he goes from A to B and then B to A, he's just traveling a total distance of 3 kilometers. So we can just plug that into our position equation. So he walks 3.000 kilometers, and acceleration is 0 because it's constant, so that goes to 0. Starting position is just 0. So that means we're just looking at the velocity of the person times t, and then all we have to do is divide 3,000 by the velocity of the person, which is 4. And if you were to solve for t here and account for significant figures, the answer would come out to be 0.5 0.750 hours is how long it takes for the person to make the round trip.